This is the future of gaming, a future powered by AI. Today, we'll explore the cutting-edge innovations that are making this a reality, from self-evolving worlds that respond to your every action to AI companions that can create and collaborate. So, grab a drink and settle in, because we're about to uncover some crazy innovations, and I think the last one especially is going to blow your mind. Brain-computer interfaces, or BCIs for short, are devices that create a direct link between your brain and the game, allowing you to control it with your mind. You might have heard of Elon Musk's Neuralink, which is an early example of a BCI. You can think of a BCI as a microphone for your brain. When we make decisions, our brain creates electrical and chemical signals. BCIs use electrodes placed near these signals to catch the activity. Then, using artificial intelligence, this data is translated into an understandable format that reflects what the brain is trying to do, i.e. mind control. This allows us to listen to the brain's intentions, much like a microphone picks up sound. Currently, this technology is in its early stages, but we're already making exciting developments. Simple action control BCI games allow basic controls like moving a character left or right based on brainwave patterns. As you can see, the technology is still fairly new and pretty clunky. Put it this way, I doubt you're going to strap on that funny looking hat when you sit down for a few evening games of Call of Duty. But as I mentioned, the technology is in development. Elon Musk's Neuralink is working on a coin-sized surgical implant which will give instant feedback from your brain to the game, or zero ping in gaming terms. Neurable is also producing BCI enhanced headphones that do almost the same thing as Elon without drilling a hole in your skull. It is not inconceivable then that BCIs may soon be combined with other technologies to create games where the player is completely immersed. The game will literally become your reality, as you will soon be able to virtually insert people into video game worlds. Something to think twice about maybe if you're a fan of games like Dark Souls. As you can imagine, the implications of this technology are massive. For a start, it will likely be combined with augmented and virtual reality technologies, which will push the boundaries of the gaming world to places that we can't even imagine. You could actually be sitting in the driving seat of a race car or wandering the streets of a city you built in Sims. And don't even get me started on horror games or first-person shooters. Finally, stretching beyond the gaming scene, we will likely see that games will be used for real-world training. We know F1 drivers already use simulators to practice, so it isn't a massive step to see them training in completely immersed game worlds with haptic suits providing G-force stimulation and the game pushing the very limits of their concentration. When you think about artificial intelligence, how intelligent do you really think it is? This is a complex question, but the answer at the moment is as intelligent as we make it. What I mean by this is that current popular AI tools like ChatGPT and Google's Gemini are constrained by the inputs and knowledge that we give them. For example, ChatGPT is super smart, but yesterday it was exactly the same as it is today, and it's exactly as smart as it will be tomorrow. It currently requires software releases by the programmers to update its logic. But what if I were to tell you that this might not always be the case? That we might eventually create self-evolving AI, needing no inputs beyond pressing the go button? In the context of gaming, this would mean self-creating games. AI that can write compelling narratives, design unique characters, and even create entire game worlds, all on its own. But what technologies would we need in order to actually create a self-evolving game? Well, the first step is something called unsupervised learning models. An unsupervised learning model can sift through vast amounts of data without any explicit instructions from game designers, and then proceed to uncover patterns and trends in the data. So, imagine your favorite game analyzing how you and millions of others play, recording every choice, action, and exploration. Unfortunately, we aren't at the stage yet where AI knows what to do with this data. It might be able to see that the vast majority of players got past a level with relative ease, but it doesn't really know why. All it can do is show this information to the game designer, who then works this out for themselves. So, Using an unsupervised learning model, AI can analyze large datasets and establish trends, like the fact that a level is easy for the majority of players. The next stage in the journey is evolutionary game design. This is where the game essentially plays itself millions of times over in a super short space of time, each time with slight variations in rules or challenges. Now imagine this, an AI creates a basic tower defense game where players strategically place towers to defend their base from waves of enemies. The AI then tweaks the rules slightly, perhaps introducing flying enemies that require new types of towers. Millions of simulated games are played, with the AI measuring factors like player success rates, tower usage, and overall enjoyment. Winning strategies, or game variations with high engagement, are then bred together. This cycle continues until the AI identifies a tower defense game that's both strategically deep and satisfying to play. Despite these innovative advancements, AI has not yet reached the capability to dynamically evolve entire levels, storylines, or core mechanics based on player data in real time. This is where autonomous content creation comes in. When we think of self-evolving games, this is the ultimate goal. An AI that can write compelling narratives, design unique characters, and even create entire game worlds, all on its own. Autonomous content creation is a way into the future, but you might be surprised to hear that it's the technologies that I've already touched on, which we already have, which form the basis. As we have discussed, AI might not yet be able to make unique games all by itself. However, it is already in place as a tool for game developers to reduce time on mundane tasks while also giving fresh ideas in the creative space. An example of this is generative adversarial networks, or GANs for short. I like to think of GANs like chameleons. They see a dataset, as a chameleon sees a colour, which they become so familiar with, they're able to create new, made-up content based on what they are given. But what does this mean for video games, you ask? Well, GANs can help with everything from enhancing visuals and game artwork to sound design to the creation of realistic animations. Imagine a game developer wanting a serene landscape with a majestic waterfall cascading down a mountain, an animation that used to take days to create. Now, NVIDIA's GAN 2 can generate a photorealistic image simply on text prompts like snow-capped mountain peak cascading waterfall. But the magic doesn't stop there. With additional tools, the developer can define the movement of the waterfall, making the water flow down the rocks and creating a misty spray at the bottom. This allows for the creation of dynamic and captivating animations that enhance the atmosphere of the game world in only a few clicks. Furthermore, GAN 2 opens doors for creating more immersive and interactive experiences, as it can also be trained and integrated into the game engine itself. Let's say a player enters a cave and encounters a dragon. GAN 2 can be used to generate different variations of the dragon based on the player's choices throughout the game. If the player has been benevolent, the creature might appear friendly and welcoming. Or, if the player has been aggressive, the creature could take on a more menacing form. This ability to adapt visuals and animations based on player interaction personalizes the experience and keeps players engaged. Beyond art and animations, GANs can also be used in game sound design as well. Jukebox by OpenAI is a fascinating experiment pushing the boundaries of AI-generated music. It's a type of GAN trained on a massive dataset of songs. This training allows Jukebox to analyze musical patterns, instruments, and vocal styles across various genres and apply them to a game. Currently, game developers perfectly match music to gameplay. But what if a game is self-evolving? You might have played a stealth version of your character all game. But if the developers of the game wanted this to be an action scene, too bad. You're probably stuck with upbeat action music, killing the vibe of the scene. Luckily, Jukebox allows games to have dynamic soundtracks that adjust to the player's progress. During a peaceful exploration phase, Jukebox might create calming ambient music. Then, as the player enters a tense combat scenario, the music could shift to a more fast-paced and dramatic soundscape. Additionally, Jukebox could be used to generate sound effects that react to the player's environment. The sound of footsteps might change from soft grass to crunching leaves as the player moves through the different terrains. This level of detail can create a more believable and immersive game world. While Jukebox is currently under development, its potential to create adaptive and immersive audio experiences within video games is so exciting. Now, I mentioned that BCIs could be combined with other advanced technologies, and sensory immersion technology is one of these. But is it really possible for a video game to affect all 5 of your senses, even smell and taste? More on that in a moment, but covering sight first. If you've tried the latest VR headsets, you know how real those visuals feel. It's like stepping into another world where the game becomes your visual reality, and you can only imagine that companies are only going to one-up themselves from here, vastly improving the tech in a short number of years. Now, it's not just about what you see, right? It's also about what you hear. Current games use surround sound to create a 3D soundscape. It's seriously cool to hear footsteps creeping up behind you like you're actually there. But imagine the future where these sounds get even more refined. Like, you could hear a pin drop and know exactly where it fell in a room around you. That's the kind of immersion that we're heading towards. Sensory immersion tech also affects how you feel as well, through haptics and temperature control. Haptics right now are pretty good. It currently involves wearing a vest that thumps every time you get shot at, or gloves that let you feel the texture of objects in game. It's like the game is reaching out and touching you. It's already super cool, but as neural technology improves, we're likely to see full-body suits which react to your emotional state, or even completely removing the suit in favor of hologram technology, which could use magnetic technology to create a virtual haptic suit, increasing your immersion while not requiring you to climb into a full bodysuit every time you feel like playing some Fortnite. Temperature control is another example of sensory immersion. Imagine playing a survival game, feeling the chill of the wind on a snowy mountain, or the heat of the blazing sun in a desert level, all from your gaming chair. This tech will make every game environment feel 100 times more real. And now for the wild card, smell and taste in games. We're talking about tech that's still super early in development, but one day, you might be able to smell the gunpowder from your weapon or the alien forest on distant planets. Or you could taste the difference between a health potion and a magic elixir. Crazy, right? It's not quite here yet, but it's on the horizon. Now for the really wild stuff. Emotional feedback loops in gaming aim to create a more dynamic and responsive environment by adapting the game based on your emotions. Emotional feedback loops achieve that in 2 steps. One is biofeedback sensors. These sensors, like heart rate monitors or skin conductivity meters, can be built into haptic suits like those mentioned previously to measure bodily responses to in-game actions. The game can then measure your emotions through data analysis, which is AI algorithms which analyze the biofeedback data to infer your emotional state. Emotional feedback in gaming isn't super new, but it's getting smarter. Some games right now can actually change the music based on how tense you feel, thanks to heart rate monitors. If you're getting frustrated, the game might ease up a bit. It's pretty basic for now, but it's definitely laying the groundwork for something much bigger. AI is about to take emotional feedback to a whole nother level. We're looking at advanced emotional recognition. Imagine an AI that doesn't just read your heart rate, but combines it with how you play, where you hesitate, what choices you make, and then figures out your emotional state from all that. AI will also be able to create personalized game pacing. Think about a game that adjusts not just the difficulty, but how long each level is, or the types of challenges you face, based on how engaged you are. Losing interest? Boom, the game throws something new at you to keep you hooked. If you think games now are addicting, wait until the game is actively trying to keep you hooked. The game's story could change in real time, reacting to how you feel about characters or plot twists. This means that every player could get a slightly different story, one that's tailored to what hits them the hardest. I imagine at this point you probably have a couple of questions. First, when will this tech actually be available? While no one can tell the future, I can tell you that AI is allowing us to advance quicker than we ever have before. Take AI itself as an example. Recently, GPT-4 was released, which is rumoured to be 10 times more powerful than GPT-5, which was released just 6 months before. It can now also generate pictures and sound, and is personalised. All this compared to text only of GPT-2. The point is, things are moving quickly, so don't expect any of these technologies to be far beyond the horizon. Secondly, who actually wants to look like a Special Forces soldier when they sit down to an evening of Call of Duty? I understand this. With the VR headset, haptic bodysuit and gloves, and all the other trimmings, you are more likely to look like Iron Man than the casual gamer. But with all things, technology is always downsizing and improving. Soon enough, your headset will read your mind, and your haptic bodysuit will be a hologram. So, not to worry.